Good afternoon, class. We're looking at Chapter 8, Further Application of Trigonometric Functions. Here's Section 8.6, Vectors. So we are going to look at the second part, dot product. All right, reminding you of what we have covered through a simple example. Weight of a piano. A piano is being pushed up a ramp, inclined at an angle of 20 degrees. With a force of magnitude 300 pounds, okay, with a force of magnitude 300 pounds, find its weight. And what you can see, this is the component of the weight. This is the component that pushes it up. And this is called the normal force. So let's see what we have been given. And of course, the angle 20 degrees is given here, which is the same as this one, because these two triangles, this is a 90-degree triangle, and so is this one. And this one is parallel to this one, and this one is perpendicular to this side. So that's actually a theorem in trigonometry that indicates that. But let's call this ABC. The force pushing it up, the magnitude is 300 pounds. It's given. So theta is 20 degrees. The magnitude F1 pushing towards the center of gravity is the weight missing. F2, the magnitude is given as 300 pounds, and F sub 3 is called the normal force. So the first thing is, what is a normal force? The normal force is a constant force applied by a surface on an object, or is a force acting perpendicular to a surface. This way, in essence, okay? Perpendicular to the surface. It makes a 90-degree angle with this surface. So, the angle BAC, this angle, and DBE, this angle, they are both the same. They are both 20 degrees. Why is that? Well, this angle is 90 degrees, everybody. Angle B. This angle is also 90 degrees. Okay? So if this is 90 degrees, okay, what happens? These two angles must add up to 90 degrees. If this is 90 degrees, these two angles must add up to 90 degrees. If this is 90 degrees, these two must add up to 90 degrees. So angle ABC, angle BAC, they must add up to 90 degrees. So angle ABC and DBE, because these two angles, let's just do it this way. This one, this angle, and this one must be 90 degrees, because look, this is 90 degrees. These two must add up to 90 degrees. If these two must add up to 90 degrees, and these two must add up to 90 degrees, and this is 20 degrees, this has no choice but to be 20 degrees. That's it. The idea. So now, so let me erase my word. So this angle, and again, this angle and this angle, okay, these two, okay, and these two, therefore, this is also 20 degrees, just as this. Now, now if we look at DBE, DBE, this is the triangle, this is the sign for a triangle, DBE. This angle, sine of 20 degrees, is the opposite, F2, over the hypotenuse, F1. So sine of 20 degrees is the opposite over the hypotenuse, F2 over F1, the magnitude. So what is sine of 20 degrees? You have to get it from the calculator. What is the magnitude of F2 is given as 300 pounds. What is the magnitude of F1? We can calculate it because now magnitude of F1 is 300 divided by sine 20. In other words, cross product, everybody. Let me, so this times that, this times that. So therefore, magnitude of F1 is 300 divided by sine of 20 degrees. You put that into a calculator and you come up with 877 pounds roughly. As far as the number of decimals, if they don't ask you, you want to go with many decimals. Okay, class? But most likely in this case, because they gave us 300 pounds, they wanted to the nearest whole number. Uh, as I mentioned, always go with more decimals to be on the safe side. All right, so that was an application problem. We're going to move on. So let's look at this example where we're going to find a unit vector. V is 4i minus 3j, reminding you that to find the unit vector in the same direction, first you have to find the magnitude. So the magnitude is square root of a squared plus b squared. For this one would be the square root of 4 squared plus negative 3 squared. And as you know, this is 16. Nine, they add up to 25, and therefore it comes out as 5. Now, a unit vector in the same direction, just divide this one by the magnitude. So you get 4/5 of I minus 3/5 of j. And you can check by evaluating the magnitude and prove that it is equal to 1. So simply put, 4 over 5 quantity squared plus negative 3 over 5 quantity squared. This is 16 over 25. This is 9 over 25, which makes it 25 over 5 or 1. And you have to take a square root, but you already know the square root of 1 is 1. So that's the proof, believe it or not. Very straightforward. So unit vector, basically find the magnitude and divide by. A ball is thrown with an initial speed of 25 miles per hour in a direction that makes an angle of 30 degrees with the positive x-axis. So with the positive x-axis makes a 30-degree angle. So this way. Find the components of the velocity vector, that means horizontal along the x-axis, vertical along the y-axis. So in other words, here's the vector with the magnitude of 25 miles and the angle of 30 degrees. That's the given. And so you want the components. So in essence, you drop a perpendicular along the x-axis, you want this component, and you drop a perpendicular along the y-axis, you want that one. And simply put, a vector is the magnitude times cosine alpha I plus sine alpha j. So this is 25, and replace the alpha with 30 degrees. Cosine, this is a common arc, so square root of 3 over 2. Sine is 1/2. So 25 square root of 3 over 2i plus 25 halves j. So the horizontal is 25 square root of 3 over 2, roughly 21.65, same units, miles per hour. The vertical is 25 halves, or simply 12.5 miles per hour. So we write the V is 25 cosine 30i plus I sine 30j. And again, this is a rough estimate. We want to find the actual speed and direction of an aircraft. A Boeing 737 aircraft headed to south maintains a constant speed of 500 miles per hour. The jet stream is 80 miles per hour in the northeastern direction. Express the velocity v sub a of the 737 relative to air and the velocity v of w of the jet stream in terms of I and j, the wind. So the aircraft is going south and the wind blows in northeast direction. Okay. So what is the magnitude here? 500. What is A or theta? Going south is making the angle with the positive side of the x-axis is negative 90 degrees. And the jet stream has the magnitude of 80 miles per hour. The direction is northeast. That means 45 degrees. This one and this. Again, north-south means negative 90 degrees, right? Okay. And northeast means 45 degrees. Therefore, we go with this formula and we say the velocity of 737, we're going to use this. Okay. 500 cosine of minus 90 degrees I plus sine of minus 90 degrees J cosine is 0, sine is negative 1, so we get negative 500 J. Same thing for the wind, 80 cosine of 45 degrees I plus sine of 45 degrees J. Okay, so this is going down, minus 500 J. That's the velocity for the aircraft, and 80 cosine of 45, sine of 45, both of them are square root of 2 over 2. So divide by 2 and you get 40 square root of 2I plus J. Both of them have the same coefficient, if you will. So again, this is going this way. This is going this way. And the actual velocity we are interested in. So we expressed both of them in terms of I and J. We're going to continue with the question. The question is, find the velocity v sub g of the 737 relative to ground. G stands for the ground, which means add them up. Now, first, I'm going to write both that answers that we got from the previous page. This is from the, because I couldn't continue on the same page. So I'm writing everything from the previous page. Then we're going to add them up. So you add them up. And when you add them up, you add up the components. This 4d square root of 2I stands alone. And this 4d square root of j will be added to this one. So we write it in this following manner. 4d square root of 2I, and then 4d square root of j minus 500 times j. I hope you see that we are combining this one and this one, okay? Find the actual speed and direction of 737 relative to the ground. Hence, of course, the magnitude is the absolute value of a squared plus b squared. So this would be raise this one to the power of 2 and raise this one to the power of 2 and add them up. So, and as far as the direction, we are talking about this angle, okay? We want this, and remember the angle that it makes with the x-axis is, we're going to call it A or alpha. Now, the true direction, okay, is going to be south, this angle east, and this angle is 90 minus alpha. So the magnitude, we will calculate it in a moment. Direction south, east, in between the angle is 90 minus alpha. So we're going to calculate this and we're going to calculate this. To calculate this one, just the square root. Now I'm going to leave it for you to verify that you put that into a calculator. So you square that. For the square root of 2 minus 500, put it into a calculator, square it, add it to this one, take a square root, and you get 447 miles per hour, roughly, again, closest to the whole number. And tan is B over A. So we're going to divide this number by this number. Again, you have to put it into a calculator. Whatever this number is, alpha would be tan inverse of this number. Alpha is tan inverse of this number. And we get negative 82.7. So this is negative 82.7. Now, what is this? These two numbers, these two angles must add up to 90. So this angle is 90 minus 82.7. So this one and this one, they must add up to 90 degrees, right? So this one is 90 minus 82.7, which is 7.3 degrees. So it's doing 447 miles per hour, due south, 7.3 degrees east. So it's very straightforward. So a quick recap. We find VA with its components, the same thing, V sub W, okay, because the speed is given for the aircraft as well as the fact that it's going due south. The wind, the speed is 80 miles per hour going northeastern, and so we can figure out V sub W using this methodology. Then we want to find the velocity relative to the ground. We add them up because those are vectors. We add them up. And then how do you find this, the magnitude? You use this formula. How do you find the angle? You use this formula. And then they're asking for the actual speed. And they are saying what is the direction. And we know it's south, east, and in between is this angle. And we found that. All right. The dot product of two vectors has many applications with the following algebraic definition. Vectors V and W, scalar real alpha. V has components A1 and B1, so A1I and B1J, or this format. W has components A sub 2 and B sub 2. Their dot product, V dot W, is A1, A2 plus B1, B2. That's by definition. The symbol V dot W is read V dot W. The dot product is also known as the scalar product or the inner product. The result is a real number and not a vector. Properties. V dot W and W dot V are the same because of the commutative properties of addition and multiplication. V dot 0 is 0 dot V is equal to 0. V dot V is the magnitude quantity squared. Alpha times V dot W is, you can distribute it, alpha dot V times V plus alpha times W. The dot product of V and W is A1, A2 plus B1, B2, or the magnitude of V times the magnitude of W times cosine theta. And so with that being the case, With that being the case, everybody, take a look at this last one. Then cosine would be this divided by this. So cosine theta, the angle between vectors, look at this last one, would be the left side, V dot W, over the magnitude of V times the magnitude of W. And of course, magnitude is square root of A squared plus B squared. In the case of a V, we're going to say A1 squared plus B1 squared under the radical. The reason we go with A1 and B1 because we have two different vectors. Let's find the dot product for this case. A is given, B is given. And so if we want to look at their dot product, simply multiply the A component, the I component, and the J component. Minus 5 times 2 plus 3 times 6. This is minus 10. This is 18. They add up to 8. What about these two? We are going to dot product A and B, and we are going to multiply the components. 4 times 3 plus 6 times negative 7. 12 minus 42 is negative 30. Okay, the dot product continues. Okay, so any two non-zero vectors, A has components A1 and A2, B has components B1 and B2, may be represented in a coordinate plane by directed line segments from the origin O to the point A with coordinates A1 and A2 and B with coordinates B1 and B2. Okay, in essence, the uh, position vector respectively. The angle theta between the two, A and B, is by definition AOB. And that cosine angle between two vectors can be found as it was mentioned in the previous page in this format. V dot W divided by the magnitude of V times magnitude of W, where magnitude of V is square root of A1 squared plus B1 squared. And V dot W, we said is A1, A2 plus B1, B2, or magnitude of V times magnitude of W cosine theta. Orthogonal vectors. In essence, it's just like think of lines perpendicular with vectors, we call them orthogonal. Two vectors are orthogonal when the angle between them is a right angle 90 degrees. The dot product of two orthogonal vectors is 0, theta equals pi over 2. Because this times cosine of pi over 2, cosine of 90 degrees of pi over 2 is 0. Parallel vectors. Two vectors V and W are parallel when the angle between them is either 0 degrees, theta is 0, the vectors point in the same direction, or 180 degrees, theta equals pi, the vectors point in opposite directions. In other words, V is alpha times W. That means if you multiply one of them by some number that you have to figure out, you get the other one if they are parallel. Finding the angle between two vectors, finding the dot product and the angle between A and B. The dot product we said is A1, A2 plus B1, B2. So 4 times 1 plus negative 3 times 2. It's negative 2. Pretty straightforward, everybody. Let's graph the vectors. If you want to graph the vectors, you basically graph these 2 points. This point and this point. This one, 4 to the right, 3 down. This one, 1 to the right, 2 up. And then from the origin, connect them. So this is one of them. 4 minus 3. This is another one. 1, 2. And now connect. And those are the vectors. Now we want to find the angle between them. So cosine theta is v dot w over the magnitude of v times magnitude of w. So we already have v dot w. The magnitude of v, it's square root of 4 squared plus parenthesis negative 3 quantity squared. And this one is the square root of 1 squared plus 2 squared. So this one, 16 and 9, 25, let's write it. 16, 9, 25. This is 1 and 4, 5. 25 comes out. 5 remains. We're going to multiply the top and the bottom by square root of 5. The bottom becomes 5 times 5 or 25. The numerator is negative 2 square root of 5. We want the angle. So this is cosine theta. What is theta? Cosine inverse of this number. And cosine inverse, you put it into a calculator, results in 100.304 degrees. And let's say 100 point. If we stop here next to the 0, it doesn't change. So the angle between is 100.3 degrees. Pretty straightforward, everybody. A quick recap. We are given 2 vectors. Okay, to graph them, simply put, plot 2 pairs, this pair, and connect it from the origin to each one. That's one vector, that's the other. You want the angle in between. Cosine is v dot w over the magnitude of v times w, and you have to put it into a calculator because it's not a common. Show that the pair of vectors is orthogonal. Well, that means the angle in between is 0. And to show that, you look at this one and say I dot j. This I is 1 comma 0, j is 0 comma 1. So 1 times 0 plus 0 times 1, and clearly it's 0. So it's very straightforward. We do the same thing here. This is 2 times 6 plus 3 times negative 4. This is positive, this is negative 12. They add up to 0. So their dot product is 0, or you show that the angle in between is pi over 2. Either way, it makes no difference. It means the same thing. Show that the two vectors are parallel. There are two ways to do that. One of them, you may notice that W is 2 times vector V. Take a look. 2 times 3i is 6i. 2 times minus j is minus 2j. Or you can say V is half of W. Either way, you're done. That's a proof. If one is a multiple of the other, the two must be parallel. The second case is to evaluate cosine theta using this formula and prove the angle in between is either 0 or 180 degrees or pi. So as you can see, the dot product, 3 times 6 is 18, minus 1 times minus 2 is plus 2. I hope everybody can see how we got that 3 times 6. And let me just write at top. So this is 3 times 6, plus the other one is minus 1 times minus 2. And the magnitude, this one, 3 squared plus negative 1 squared is 10 under the radical. 6 squared is 36, minus 2 squared is 4. They add up to 40. So you have 20 in the numerator, 400 under the radical, which is the same as 20, and you get 1. So if cosine theta is 1, theta is cosine inverse of 1, which must be 0. Okay, so a quick recap. Two vectors are orthogonal if their dot product is 0, which means they make a 90-degree angle or power 2. Two vectors are parallel if they make a 0-degree angle or 180-degree angle in between. There are two ways to do it. One is to find the angle in between. In the case of a parallel, one is that you notice one of them is a multiple of the other. Vector projection. Again, remind you of the dot product. Decompose a vector to two orthogonal vectors. So think about this. If you have this vector, drop a perpendicular along the x-axis, drop a perpendicular along the y-axis. These two are the components, horizontal and vertical components. Okay. And these two make a 90-degree angle. V1 and V2 make a 90-degree angle. That's the idea of decomposing a vector to two orthogonal vectors. And along the x and y axis, it's fairly easy to see, okay? But it doesn't have to be along those. So the component of a V along W may be found by projecting the end point of V onto the line L containing W. For this reason, the magnitude of V times cosine theta is sometimes called the projection of V on W and is denoted by projection of V on W, which is a vector, with magnitude of component of V on W, which is a scalar. So again, this one, along the x and y axis, we have V1 and V2. This one, along the y-axis is very clear, but along the x-axis is on the negative side of it. But nevertheless, this is still a 90-degree angle. Now, this is somewhat interesting. So you're looking at this one that is the weight of the box towards the center of gravity, center of the earth. The components that you make up, you normally make up a component along the piece that it's rolling up. Okay. The surface, okay. So it's parallel to the surface. And then another component that is perpendicular to the surface. And this component, F2, the way this one is given, as you recall, this is called the normal force. I've explained that to you. And this is the force, perhaps, that is trying to push it down, and you have to undo it by pushing it up. And this is the complete weight of the box in this case, or anything that is going up the ramp. So component of V on W is the magnitude of projection of V on W, which is V dot W over the magnitude of W squared times W, which becomes the magnitude of V cosine theta, V dot W over magnitude of W. In other words, vector projection of V onto W. V1 is parallel to W. V2 is perpendicular to W. And this is what we get. So it's important to know when you're projecting it onto some vector, okay, there's a portion that is parallel to that, and there is a portion that is perpendicular to that. We want to find the vector projection of V equals I plus 3J onto WI plus J. Decompose V into two vectors, V1 and V2, where V1 is parallel to W. So this times some number, just for the sake of argument. And to W, and is V2 orthogonal to W. So V2 is so let's look at this one. So the components are 1 and 3. This one, the components are 1 and 1. So we go to the XY axis, 1 and 1 and 1 and 3. They give us the two vectors. So this is the V, this is the W, which means what we want to decompose the V into two vectors, V1 and V2. V1 is parallel to W. So extension of that, because it's easier actually to graph it. You have to imagine this is an axis. So you want to drop a perpendicular, okay, and this becomes the one which is parallel to that, V1. And this one this is V2. That's the idea, to understand what we are looking for. So one more time. These are the two vectors, and so you want V will be projected onto W. So you drop it, so you extend the W, both sides indefinitely. You drop a perpendicular, and what you're looking for, this one is parallel to this one. In other words, it's the same as W times some number. Maybe, of course, this is larger. You can see it from the graph. Could be smaller, it doesn't matter. But it's this one times something, and this is perpendicular to that. And the sum of these two is the original vector I plus 3j, so you know that. Okay. And so first, let me erase my work. So V1 is projection of V onto W is V dot W over the magnitude of W squared times W. Okay, so let's look at VW. This is 1 times 1. This is plus 3 times 1. Again, remember this X. Let me just write. So this is 1I, 1J. Okay, this is 1I. Okay. So the V dot W represents the the dot product represents the magnitude too. So 1 times 1 and 1 times 3, we add them up. Now what about W? Look at this one. Square root of 1 squared plus 1 squared, and you're going to square that. And then times W, which is I plus J. So we are going to simplify this, and I hope you see that this one is 3 plus 1, 4. This one is square root of 2, comes out, becomes 2. 4 over 2 is 2 times W. And again, I hope you see that. The result is some number times W. 2 times W is 2I plus 2J. So that's the vector. Very simple. The other one, you really don't have to do anything. V sub 2 is V minus V sub 1. So this one minus this one. And this is minus 2I. With this one becomes negative I. This is minus 2J. With 3J becomes plus J. And that's exactly what I was showing you. You drop a perpendicular. If you extend this indefinitely, you drop a perpendicular. This becomes your V1. This becomes your V2. And because the sum is V, if you find one of them, you find the other one. And again, in short, when you go through this process, it should give you some number times the one that you're projecting it into. Okay, that's how it works. Find the work done in pushing an automobile along a level road from a point A to another point B 40 feet from A while exerting a constant force of 90 pounds. Okay, let's discuss a little bit of it. Physics. Work is the result of force being applied to an object over some distance, which in turn may change the object's total energy. When the amount of force varies, use calculus. When it's constant, work is simply force dot distance, or simply W. The work is FD. So what is given? Force is F equals ma. Weight is F equals mg, for example, where the gravitational force, where the acceleration is due to gravitational force. Work is W is F dot D, which is the magnitude of F times magnitude of D times cosine theta. So the dot product gives us the force. So in this case, given F is 90 pounds, D is 40 feet, and we are going in the same direction. In other words, theta is 0. So W is simply F times D, 90 times 40, which makes it 3,600. The units, foot-pound. So 3,600 foot-pound. As far as other units, let me, go over something that you may have seen in physics, or at least, you're um, looking at it now for the first time. It's fine, and at least you've been exposed to it here, and that is joules. 1 joule equals 1 Newton times meter. 1 kilogram meter squared over second squared. Joule is the unit of work or energy in the international system of units called SI. It is equal to the work done by a force of 1 Newton when its point of application moves 1 meter in the direction of action of the force. James Prescott Joule. That's the unit is named after him. It equals 10 to the power of 7 ergs, or approximately 0.7377 foot-pounds. The relationship between the old British system, also known as US customary, versus the SI, the international system. You don't have to worry about it too much at this point. All right. A child pulls a wagon with a force of 15 newtons. The handle makes an angle of 30 degrees with the ground. Okay, so going this way, the angle is 30 degrees. Find the work done in moving the wagon 100 meters. So what is given? The force is given as 50. The distance we cover is 100, and the angle we cover is 30 degrees. Because it's a constant force, we simply use magnitude of F times magnitude of D times cosine theta. The magnitude of F is 50. The magnitude of the distance is simply 100, and cosine of 30. So we have 50, 100 square root of 3 over 2. $5,000 divided by 2 is 2,500. Square root of 3 joules is the exact answer. Roughly, you can change it if they ask you what to do. Okay, so this is the exact answer. Quickly, I'm going to go over the methodology of a vector in a different manner, but this is good enough and you're done. Again, we are looking at the same question. The force is given, the distance is 100 meters that is covered. So we position the vectors in a coordinate system in such a way that the wagon is moved from 0, 0 to 100, 0. The motion is from A equals 0, 0 to B equals 100, 0. So we make it a vector in the following. So we're going to go from this point to this point. This is 0, 0. This is 100, 0. Okay. The angle is 30 degrees. That's the force that we put. And so the components, if you drop the perpendicular to the x-axis, 50 cosine of 30 degrees I, because this is 30 degrees. If you drop perpendicular to the y-axis, 50 sine of 30 degrees J, okay? So the distance AB, the vector AB is 100I because it's in the positive direction of x. And the force is 50 cosine 30 degrees I plus sine 30 degrees J. And cosine is square root of 3 over 2. Sine is 1/2, which results in, drop the 2, we get 25 square root of 3I plus 25J. And the work is their dot product. So F dot D or F dot AB. So just write each one. F is this vector. These are the components, everybody. And AB is this vector, 100I plus 0J. You multiply these two numbers, you get 25 squared of 3 times 100, plus you multiply this one, 25 times 0. This is how you multiply dot products. This goes to 0, and that gives you the same answer as we had before. So this is the second method of solving the same question.